Welcome to the Sleepy Science channel, and hello, I'm so happy you came here. Perhaps you had a difficult day, or perhaps you prefer to fall asleep to profound reflections and cosmic puzzles rather than sheep counting. In any case, the trip is for you tonight. The only thing you can do is sleep. Allow your body to become lighter as though gravity itself has loosened, your breathing to calm, and your thoughts to rest. We're not just stargazing tonight for that reason. We are traveling through the Milky Way, our home galaxy. For more than 13 billion years, a massive spiral of stars, dust, and dark matter has been slowly rotating in space. But there are secrets hidden beneath its beauty. Invisible forces, rogue stars, and old relics that contradict our preconceived notions. From massive collisions to stars older than the galaxy itself, we'll make our way slowly from its spiral arms to its hidden secret core. You will learn about stellar nurseries, black holes, and the intriguing unresolved tale of a galaxy that is still expanding. As you go to sleep tonight, you might be surprised by some of the things you hear, or at the very least, curious. Before we get started, think about liking and subscribing to the channel if these serene, inquisitive discoveries help you relax or provide you with a peaceful way to conclude your day. It also makes it easier for others to find their way here. One drowsy person at a time. Let's get started. There will be another collision between the Milky Way and other galaxies. Although our galaxy may seem like a secure place to call home, it was formed from the remains of other galaxies. Smaller galaxies have been drawn in, unraveled, and their stars scattered into tidal streams that round the disk by the Milky Way over billions of years. The Sagittarius dwarf is one such galaxy that is now undergoing disintegration. Andromeda is slowly approaching from afar in the night sky, around 4. The two giant spirals will collide in a cosmic collision after 5 billion years. The galaxy's shapes will shift forever, folding into a new form, huge and peaceful, yet stars will hardly ever collide. Not even galaxies last forever. They change, clash, and start over. The Milky Way itself is not as old as some of its stars. Not all of the Milky Way's stars were born here. It appears that some halo stars, which are old metal-poor stars that travel in lengthy, slanted orbits, existed before the Milky Way was completely formed. These stars may have formed in tiny primordial galaxies that collided with our own billions of years ago, according to astronomers. Nearly no heavy atoms can be found in their chemical signatures, indicating that they were created soon after the Big Bang. Like elder spirits from a time before spirals and before order, they travel slowly and high above the galactic plane. We saw a younger, wilder cosmos in their light, one that was still figuring out who it was. Over 828,000 kilometers per hour is the speed at which our solar system circles the Milky Way's center. That's over 230 kilometers per second. Even so, a single orbit around the galaxy takes roughly 225 million years. We refer to this course as a galactic year. Since the formation of the solar system, we have only made around 20 orbits of the Milky Way in Earth time. We were in a completely different cosmos when the first dinosaurs appeared. Today's stars weren't always close by, and they won't be forever. Everything is moving, slowly, silently, forever. The Earth rotates while we sleep. The solar system as a whole moves forward through a moving galaxy while the moon orbits. The galaxy continues to expand. Despite its age, the Milky Way is not yet complete. It is still collecting stuff now. Its halo is fed by streams of dark matter, gas from the intergalactic medium, and stars from dwarf galaxies that have been captured. It develops throughout time like a gravitational structure rather than a live organism. Through infilling clouds, some of this expansion occurs in silence. In other cases, it is accompanied by disturbance, with satellite galaxies being ripped apart and their stars dispersed throughout the sky. The dinosaurs did not live in the same cosmos as you do now, and it might be much bigger than the one your distant descendants may know. The remnants of 1,000 smaller worlds were used to stitch it. The number of arms in the Milky Way is unknown. It seems like we ought to be aware of it. How many arms radiate outward from our own galaxy's core? However, it is difficult to see the entire structure from deep inside the disk location. Remote areas are obscured by dust clouds. The stars blend into each other. Astronomers thought there were 4 main spiral arrows for many years. Recent findings indicated that there may be fewer, or that the arms divide and twist in more intricate ways than anticipated. Some disintegrate into pieces. Others encircle without warning. The Milky Way is a live, complex swirl of stars formed by forces we still don't completely understand, not a neat pinwheel at all. The core throws forth rogue stars. A small percentage of stars are hurled outward at incredible speeds, fast enough to completely escape the Milky Way, while the majority glide peacefully through the galaxy. Hypervelocity stars are what these are. Some are the remains of binary systems that were upset by the galaxy's extremely enormous black hole. One star disappears after falling in. The other is sent into the darkness at a speed of more than 1,000,000 kilometers per hour. Like luminous comets with no way back, these rogue stars move alone and far from the galactic plane. They serve as a reminder that peaceful expulsions that send stars hurtling into intergalactic night can occur even in a galaxy that is gravity-bound. Andromeda and the Milky Way are headed toward collision. Located more than 2 million light-years away, the Andromeda galaxy is a faint smudge that is visible to the unaided eye well above the horizon. It is a spiral that resembles our own. Nevertheless, it is steadily approaching us. Around 4, the Milky Way and Andromeda will collide in 5 billion years. It will not be as violent as you might think. Stars are too far apart to collide head-on. However, both galaxies will be distorted into lengthy, arcing arcs by their gravity. The tails of the tides will curve outward. Black holes can spiral in unison. Additionally, the 2 galaxies will combine to form a single, bigger system after billions of years. It will be a graceful, leisurely dance. Our home's future is inscribed on the stars. Some stars have reverse orbits. The majority of the Milky Way's stars travel in the same general path around the center. However, not everyone abides by the rules. Some stars orbit counter to the galaxy's main rotation, moving in retrograde, particularly in the outer halo. These stars were probably created in dwarf galaxies that were subsequently absorbed, and they came from somewhere else. A silent indicator of their alien origin is their inverted motion. The cosmos seems to be moving with the weight of past memories. The gradual, deliberate turning of stars against the stream preserves stories of cosmic meetings and ancient mergers, rather than light. Dozens of dwarf galaxies might have been consumed by the Milky Way. The Milky Way has not expanded in isolation over billions of years. It has eaten. Faint, luminous partners, or small galaxies, have drifted near, been drawn into its gravitational pull, and gradually disintegrated. Our halo disk, or stellar streams, now includes their stars. Astronomers have used star motion and composition analysis to identify a number of these mergers. The Enceladus merger was one very significant event that added a lot of stars and might have changed the galaxy's initial structure. The spiral in the Milky Way is not perfect. It is a composite constructed from the remnants of numerous smaller worlds sewn together by silent collisions. The origin of stars can be inferred from their chemical composition. Each star is born with a distinct chemical fingerprint, a pattern of atoms. Astronomers can determine the history of a star by examining these signs. Heavy metals like calcium and iron are abundant in some stars, indicating that they evolved in areas with a lot of metal. Others were created while the universe was still young and are almost pure hydrogen and helium. Because of these distinctions, astronomers are able to classify stars into families, discover long-forgotten mergers, and piece together the secret history of the Milky Way's birth. In this sense, chemistry turns into a sort of time machine that allows us to read the stars' pasts like a line of old poetry and light. Stellar streamers from torn galaxies fill the sky. Thin ribbons of stars extend in arcs and curves across the sky. They are hardly perceptible yet, when precisely plotted, are unmistakable. The remains of smaller galaxies that strayed too near the Milky Way and were yanked apart are known as star streamers. Tidal forces smear their stars throughout space as they orbit, creating delicate, lengthy trails that retrace their previous routes. Some form spectral halos that encircle the galaxy. Others plunge into the center. The Milky Way was formed over billions of years by silent mergers and collisions, as evidenced by these streams. Like a tree, the galaxy bears the rings of its history in each strand of light. It is a distorted Milky Way. Our galaxy is not a perfect spiral that lies flat. Its disk creates a beautiful wave over the stars by bending downward on one side and upward on the other. Before radio telescopes documented the hydrogen gas that extends well beyond the sunlight, we were unaware of this tiny warp. Scientists thought the deformation might be the result of clusters of dark matter twisting the structure from below or satellite galaxies gently pulling on the Milky Way's borders. The warp shows that even galaxies are never completely at rest, like rippling in a vast spinning sheet. They respond to unseen forces by bending, flexing, and changing shape over time. The Milky Way may appear to be slowly dancing across space when viewed from a distance. You can only see roughly zero. With the unaided eye, 0.00003% of the Milky Way is visible. A few thousand stars may be visible under a clear, dark sky, distant from cities and streetlights. That appears to be an ocean of light to the human sight, but it is hardly more than a droplet. There are more than 100 billion stars in the Milky Way. Most are out of sight. Some are hidden by heavy, dusty curtains. Others are out of our line of sight or too dim. On moonless evenings, the Milky Way's pale streak across the sky is only the innermost whisper of the entire galaxy. Almost all of the enormous river of starlight that surrounds us is invisible to us because it is too big to comprehend from within. The pace at which stars orbit the galaxy varies. Stars in the Milky Way wander more freely than planets in a solar system, which follow tidy paths around their stars. Others drift slowly along the periphery, while others speed ahead in the interior parts. Spiral arms arise as a result of this speed differential. They resemble slow traffic jams of gas and stars traveling across space rather than being solid objects. These density waves cause additional stars to appear as they travel through, illuminating the arms in white and blue curls. This swirl, which moves in and out of these patterns over time, includes our own sun. There is no clock in the galaxy. We're floating along in a stream. There is something we cannot see that keeps the cosmos together. The Milky Way shouldn't exist, according to logic. Our measurements of stars, dust, and gas indicate that the galaxy's outer edges are spinning too quickly. They ought to be hurled into the air, dispersed like leaves during a tempest, and yet they are still there. Dark matter is the solution. This enigmatic material doesn't emit, reflect, or shine any light. However, it exerts gravity, and it is so abundant that it greatly exceeds all of the galaxy's observable matter. Although we don't know what dark matter is, we do know that the Milky Way would disintegrate in its absence. Everything is held in place by the unseen scaffolding. At its center is an extremely huge black hole. A gigantic black hole, known as Sagittarius A star, is a unique point of gravity located at the very core of the Milky Way. Its mass exceeds that of the Sun by more than 4 million times. Its space, however, is smaller than Mercury's orbit. Although we can't see it directly, we have seen stars in the vicinity circle it at amazing speeds, creating invisible circles in the empty space. As they spiral into the event horizon, gas and dust can occasionally collapse inward and flare with X-rays. Sagittarius, an asterisk, is currently sleeping. It might, however, have blazed like a quasar long ago, illuminating the galaxy from within. It pulls stars into a steady, unrelenting dance, acting as the silent conductor of the Milky Way's heart. There is a peanut-shaped bulge in the Milky Way. Astronomers made an unexpected discovery when mapping the galaxy's center. The middle bulge is shaped like a three-dimensional peanut rather than a smooth, round ball of stars. When viewed from the side, it resembles a twisted hourglass formed of stars, swelling in the center and narrowing at the ends. The galaxy's core bar, a thick band of stars that rotates slowly and gradually buckles and puffs upward, is most likely what created this odd geometry. Gravity, billions of years of motion, and the cumulative rhythm of star orbits all shape these interior structures. Although the galaxy in which we live is spiral, its core is complicated, complex and alive, not flat or tidy. The spiral arms are shaped by stellar nurseries. The spiral arms of the Milky Way are not just composed of stars, they are made from the stars' birthplaces. Throughout the galaxy, massive clouds of molecules, dust, and hydrogen float. Additionally, these clouds are crushed and illuminated by newborn suns as they move around the spiral arms. Known as stellar nurseries, these areas are tumultuous, bright, and dynamic. The arms are painted with brilliant blues and silvers when the clouds are illuminated by ultraviolet light from new stars. These creative outbursts outline the spiral form, casting silent fire along the galaxy's arcs. Long ago, one of these clouded cradles gave birth to all stars, including the Sun. There is a huge halo around the Milky Way, something far more diffuse. A spherical halo that envelops the entire galaxy is located beyond the fat spiral disk. It has massive amounts of dark matter, globular clusters, and old stars. This halo is almost undetectable, but it could contain most of the mass of the Milky Way. Its stars orbit in long, sluggish arcs that almost never contact the disk, dispersed thinly over great distances. The shells and streams of stars that were ripped from smaller galaxies and left behind like cosmic fossils, as well as the remains of old galaxy mergers, are likewise preserved in the halo. Though silent and dark, the galaxy's outer memory is still active and continues to influence the Milky Way's future. There are more than 150 globular clusters in it. Globular clusters are some of the galaxy's earliest objects. Hundreds of thousands of closely packed stars form compact spheres. In the halo, they circle the galactic center like moths around a far-off flame. Some of these clusters are almost 12 billion years old, have stars that predate the Milky Way, and are exceptionally stable. Since their stars evolved before the cosmos had time to produce many of the heavier elements, they are metal-impoverished. As time capsules, they contain hints about the galaxy's formation, its diet, and the environment of the early universe. Gleaming in the darkness, these silent golden spheres slowly float above and below the galactic plane. The galaxy continues to expand. Despite its age, the Milky Way is not yet complete. It is still collecting stuff now. Its halo is fed by streams of dark matter, gas from the intergalactic medium, and stars from dwarf galaxies that have been captured. It develops throughout time like a gravitational structure rather than a live organism. Through infilling clouds, some of this expansion occurs in silence. In other cases, it causes disturbance, with satellite galaxies being ripped apart and their stars dispersed throughout the sky. The dinosaurs did not live in the same cosmos as you do now, and it might be much bigger than the one your distant descendants may know. The remnants of 1,000 smaller worlds were used to stitch it. The core throws forth rogue stars. A small percentage of stars are hurled outward at incredible speeds, fast enough to completely escape the Milky Way, while the majority glide peacefully through the galaxy. Hypervelocity stars are what these are. Some are the remains of binary systems that were upset by the galaxy's extremely enormous black hole. One star disappears after falling in. The other is sent into the darkness at a speed of more than 1,000,000 kilometers per hour. Like brilliant comets with no way back, these renegade stars move alone and far from the galactic plane. They serve as a reminder that peaceful expulsions that send stars hurtling into intergalactic night can occur even in a galaxy that is gravity-bound. The rate of star formation is decreasing. The Milky Way used to be more active, exploding with new stars formed from thick, collapsing clouds. However, the rate has reduced in recent eras. Although there is still gas, much of it is heated, dispersed, or trapped in shapes that prevent it from collapsing. The galaxy is settling, but it is not finished producing stars. Star formation peaked billions of years ago, according to astronomers, and has been dropping ever since. This only indicates that we are living in a more tranquil era, not that the end is imminent. A middle-aged, mature spiral that is still producing stars, but is not in a rush. Before the Milky Way had a disk, some stars formed. Over time, the disk, the wide, flat spiral that we know as the Milky Way, formed. However, some of our galaxy's stars are older than the disk itself. These old stars were created when the galaxy was still forming, a loose cloud of stars, gas, and dark matter steadily compressing inward. They are primarily found in the halo, or the thick disk. Astronomers can see into a time before spirals and before structure by examining their speed and composition. These stars are the galaxy's elders, silent witnesses to its formation and the gradual long-term formation of the place we now call home. Between 225 and 250 million Earth years make up a galactic year. Every few 100 million years, the Sun completes one complete orbit around the Milky Way's core. This enormous cycle of motion, which dwarfs all of our calendars, is known as a galactic year. Whole epochs develop, continents drift, and species rise and fall in the time it takes for the Sun to complete one orbit around the galaxy. We are believed to be roughly halfway through one of these orbits at the moment. Dinosaurs had not yet appeared, and the supercontinent Pangaea had only started to fragment when the solar system was last at this section of its trajectory. The languid pulse of cosmic time is a galactic year. Less than 25 galactic orbits have been completed by the Sun, in all of its fourth. The Sun has only made about 20 orbits around the Milky Way in its 6 billion years of existence. That's less than you might think, given its amazing speed of around 830,000 kilometers per hour. However, each circle takes hundreds of millions of years due to the size of the galaxy and the length of the Sun's course. The stars are frequently perceived as being old and immobile. On a galactic scale, however, our solar system is still young, a new arrival in a city of more established, well-traveled suns. Though it is still early in its convoluted history, we are a part of the galaxy's motion. Newton's theories are not supported by the Milky Way's rotation. Just as outer planets orbit the Sun more slowly, stars farther from the galactic center should orbit more slowly, according to Newtonian physics. However, stars in the outside Milky Way circle at nearly the same speed as those in the core. This goes against what is typically expected. Astronomers think that dark matter, an unseen, unidentified type of mass that envelops the galaxy in a massive halo, is the cause. The galaxy wouldn't be able to survive without dark matter. The math works with it. The reason the Milky Way rotates like a solid wheel is not because we fully comprehend it, but rather because of an invisible force. There are massive molecular clouds throughout the galaxy. Large, dark clouds of cold gas, the building block of stars, are dispersed throughout the Milky Way. These molecular clouds can be hundreds of light-years broad and are primarily made up of hydrogen molecules and dust particles. Gravity starts to collect material in their cold, dense centers, creating clumps that eventually collapse into new planets and stars. Some of these clouds seem as black patches against the starry sky because they are so big and so cold. that they completely block out visible light. Tucked away in curtains of gas and shadow, these are the galaxy's wombs, quiet, secret locations where the future begins in silence. Like storms, supernovas agitate the galaxy. Cataclysmic supernovas are the explosions of huge stars nearing the conclusion of their existence, occurrences so strong that they can momentarily eclipse entire galaxies. These explosions cause more than simply death. Supernova shock waves compress neighboring clouds and start fresh star formation waves as they travel through the interstellar medium. With heavy metals like iron and gold formed in the dying star's core, they enhance the surrounding area. In this sense, supernovae disrupt, fertilize, and reshape everything in their vicinity, functioning as storms within the galactic ecology. They are the destructive, luminous, and essential moments of chaos in the cosmos. Large areas of star formation are hidden by dust. There is a lot of light in the Milky Way that we cannot see. Clouds and tendrils of interstellar dust, which is composed of small granules of ice, carbon, and silica, are found across the galaxy. It blots out stars and entire nebulae in visible light, obscuring large areas of space. However, star formation goes on behind this curtain. Through the dust, glittering nurseries full of young suns can be seen with infrared telescopes. What appears to be darkness is frequently a cradle. Although it conceals, the dust contributes to the process by absorbing energy, assisting in the cooling of gas, and protecting sensitive stellar formation phases. Often what appears to be empty is the start of something positive. The galaxy is filled with gas clouds that are starless. Not all gas clouds turn into stars. Astronomers have discovered enormous frigid clouds that appear destined to disintegrate but are still dark and dormant throughout the Milky Way. Some are too hazy. Others might be stabilized by internal turbulence or magnetic fields. Like quiet possibilities, these starless clouds drift over the galaxy, abundant in molecular hydrogen but not fused. One day they might catch fire, or they might float until outside forces tear them apart. They recycled their gas into other areas. Perhaps waiting for the right prod to ignite something new, the galaxy holds its breath in these clouds. Matter is recycled throughout the generations in the Milky Way. Stars change over time. They burn, they die, they live. They also give their stuff back to the galaxy when they die. Heavy elements were dispersed by supernovas. The outer layers are shed by red giants. Nebulae that are planetary wander off into space. After entering the interstellar medium, this enriched material cools, condenses, and eventually creates new planets, stars, and even life. All of your atoms have gone through this cycle, created in a star, dispersed throughout space, and reassembled into a new shape. The Milky Way is a powerful force for rebirth rather than a stagnant stage. It makes, unmakes, and starts over as it breathes in time with its stars. There are hints about the early universe in metal-poor stars. Metals are more than just iron or gold in astronomy. Any element heavier than helium is one of them. Since they originated before previous star generations had a chance to create and scatter them, the earliest stars in the cosmos possessed virtually none of these metals. Today, astronomers search the Milky Way's halo for metal-poor stars. The chemical conditions of a bygone era are preserved by these faint and old stars. By examining their makeup, we may see into the early universe, into the time immediately following the Big Bang, before galaxies had fully developed and the galaxy itself had taken on its entire form. They are light-based fossils. Some celebrities stray far from their birthplace. The destiny of a star is not always determined by where it was born. Many stars gradually separate from their parent clouds because of orbital resonance, gravitational interactions, or the gradual pull of spiral arms. Some stars are hurled into the halo or across the disk at great speeds. Others progressively migrate as they spiral around the galaxy, changing their orbits inward or outward. It didn't even start with our Sun. The Milky Way is anything but motionless as one follows the trajectories of its stars. A galaxy teeming with activity, trade, and silent displacement. A star's home might only be temporary. Tens of thousands of light years may separate the galaxy's habitable zone. The Milky Way might contain its own galactic habitable zone, similar to how Earth orbits the Sun in a Goldilocks zone that is neither too hot nor too cold for life. This area is believed to be situated between the outer margins of the metal porosity, where planet formation may be more difficult, and the hazardous inner core, which is full of radiation and gravitational turmoil. A broad band with stable conditions, a modest star density, and an abundance of elements like carbon, oxygen, and iron is located somewhere in the middle. This area includes Earth, one peaceful orbit in a huge whirlpool where life may not be the only thing trying to establish itself. There is no defined structure to the spiral arms. The spiral arms of the Milky Way are not composed of fixed stars, despite their appearance as sweeping, permanent patterns etched into the galaxy's disk. Rather, they are patterns, density waves that cause gas to compress and new stars to form as they move around the disk. After drifting into these arms, stars shine for a while before drifting out once more. Like a traffic bottleneck on a highway, the spiral structure travels at a different speed than the stars. It appears to be form and order from a distance. From the inside, it's a pattern of fluctuating motion that is held together by time and gravity. It's never motionless and always flows. Cosmic radiation hums throughout the Milky Way. The galaxy burns with energy that is more enigmatic than visible light. Every second, cosmic rays, high-energy particles produced by faraway galaxies and supernovas, stream across space and pass through your body. Black holes and dying stars emit glimmering X-rays and gamma rays. Pulsars, gas clouds, and the frigid breath of hydrogen are all sources of radio waves. What light cannot expose is revealed by these unseen hums, the ancient fires still blazing in the galaxy's bones, the violence, the magnetism. Only a small portion of the Milky Way's whole spectrum is visible when gazing up at the night sky. A hidden symphony in the darkness, the galaxy hums softly beneath the stars in a variety of hues and frequencies. The core is surrounded by a massive gamma-ray bubble. Two enormous ghostly lobes of high-energy light stretch tens of thousands of light-years above and below the galactic center. Only recently were the Fermi bubbles discovered. Like twin balloons, they radiate gamma rays from the center of the Milky Way. Nobody knows for certain what caused them. They might be the legacy of a violent star creation that once blasted through the core, or they might be the remains of a long-gone eruption from the central black hole. In any case, these massive structures are unseen by humans and silently wander throughout the galaxy. They serve as a reminder that there is more to the Milky Way's history than meets the eye. Radiance-wrapped echoes of carnage far above our familiar constellations. Between large arms, we inhabit a little spur. One of the great spiral arms of the Milky Way does not contain our solar system. Rather, we inhabit a little structure known as the Orion Spur, a rather peaceful starry lane tucked away between the arms of Perseus and the bigger Sagittarius. Although it's not particularly lively or dense, that might be the reason we're here. There are fewer huge supernovas in the quiet between galactic highways. Less often, radiation storms occur. It's possible that life on Earth took its time to arise and develop because of this peaceful region. The galaxy appears bright and dramatic from the periphery. However, we discovered just enough tranquility in this peaceful environment to allow complexity to develop. The center of the Milky Way is formed like a bar. Astronomers perceive a thick, elongated bar of stars that crosses the center of the galactic core in infrared light, resembling a luminous bridge rather than a perfect circle. The inner spiral arms are shaped by the gravitational pull of this slowly rotating bar. Spiral galaxies frequently have bars like this one. They are created when disk stars start to move inward and accumulate along a central axis. The bar eventually stabilizes, agitating gas, igniting new stars, and supplying material to the central black hole. It is a dynamic engine that shapes the galaxy's core from within, not merely a shape. It is a component of the local group, which is a broader structure. There is more to the Milky Way than meets the eye. It is a member of the local group, a tiny cluster of more than 50 galaxies that are all moving through space together. With their own families of satellite galaxies, the Milky Way and Andromeda are the two largest members. Smaller dwarfs, faint ellipticals, and star-poor galaxies composed almost completely of dark matter are scattered about them. The local group, which spans more than 10 million light-years, is connected by gravity rather than just proximity. Even if we live far apart, we are all connected by the unseen threads of our shared motion and attraction to one another. Local group galaxies are gravitationally bound. The galaxies of the local group are not drifting apart, even if they are quite far apart. Actually, a lot of them are approaching each other gently. Their courses are curved over millions of years by gravity, which keeps them in a sort of slow-motion ballet. Like moons, some of the tiniest galaxies circle the Milky Way, looping and descending until they dissolve into streams. Others float on their own, but they are bound together by a web of collective motion. This group might get smaller over time. Galaxies can be absorbed, fade, or combine. Time, inertia, and gravity's vast reach have brought this family of cosmic islands closer together rather than making it a static configuration. There are two components to the galaxy's disk, thick and thin. From a distance, the Milky Way's disk appears flat, yet up close it is layered. We live on the thin disk. Young stars, open clusters, and star-forming gas are all present in this broad, dense plane. However, the thick disk, which is older, puffier, and more dispersed, is located above and below it. Older stars with fewer heavy elements are more common in the thick disk. Their highly eccentric and inclined orbits indicate that they were agitated by early galactic collisions or originated under unusual circumstances. The disk of the galaxy is irregular. Like silt deposited on the bottom of a cosmic ocean, it has been stacked, sculpted, and molded throughout time. The disk is threaded by the galaxy's magnetic field. A massive magnetic field that stretches across the disk, rises into the halo, and weaves through the interstellar medium is present throughout the Milky Way, despite being unseen to the naked eye. Although this force is faint by earthly standards, it influences the motion of cosmic rays, the collapse of gas clouds, and the movement of stuff across space beyond galactic distances. It twists into loops that defy easy explanation, aligns with spiral arms, and forms arcs above the plane. Radio telescopes and meticulous analysis are needed to study it. But there is no denying its existence. There is more to the Milky Way than just light. It has a faint pulse that runs through its bones and breathes with magnetism. There are many unseen structures in the interstellar medium. There is more than emptiness between the stars. A thin mixture of gas, dust, and plasma, known as the interstellar medium, moves through the Milky Way like a fog. It is largely unnoticeable to the unaided eye. However, it exhibits a remarkable intricacy when observed through radio and infrared telescopes. It creates shock waves, filaments, bubbles, and cold, dense clouds that give birth to stars. Large holes are created in it by supernovas. Shapes formed by stellar winds ripple across light years. Instead of being a vacuum, the area between stars is a dynamic network of matter and magnetism, the silent fabric that finally gives rise to life and galaxies. We are continually being bombarded by cosmic rays from the cosmos. High-energy particles, primarily protons and atomic nuclei, that were created by long-gone stellar explosions, go through your body every second. Cosmic rays like this are seen all throughout. They move at nearly the speed of light, bouncing off clouds, bending through magnetic fields, and sometimes hitting atoms in the Earth's atmosphere, where they produce secondary particle showers. We rarely notice them, but they are carrying messages from the violent harps of stars, evidence of past supernovas, stories from across the galaxy, and remnants of distant acceleration. The cosmos is communicating in particles, in stillness, and in lightless rays, even when you are sleeping. Although it appears as a clean, smooth spiral in many diagrams, the galaxy is not symmetrical. There are imbalances in the Milky Way. The disk seems thicker on one side. Spiral arms vary in length, curvature, and brightness. The outer disk has an uneven warp. There is also a tiny discrepancy in the number of stars between the hemispheres. These asymmetries could be the result of dark matter, previous mergers, or gravitational collisions. They remind us that galaxies have character and depth because, like living beings, they bear the scars of collisions, the wrinkles of time, and the peculiarities of uneven growth that are remnants of their past. Our halo might include the earliest known star. Astronomers found a star that might be almost as old as the universe itself, floating in the halo far above the galactic plane. Its near absence of heavy elements is indicative of stars that were formed shortly after the Big Bang, before the universe was enriched by generations of supernovae. Long before the Milky Way was completely formed, probably more than 13 billion years ago it formed. Low in mass but rich in history, it now glows softly crimson and quietly. It's more than a star. It is a living remnant from the very beginning of the cosmos, a time capsule. In the Milky Way's inner regions, the galaxy's center rotates more quickly than its periphery. Stars in the center orbit at a far faster speed than those in the periphery, with mass from stars, dust, and the incredibly enormous black hole, Sagittarius. An asterisk. The gravitational pull is greatest close to the core. As a result, stars rush through orbits that are faster and tighter, completing revolutions in a matter of millions of years. Stars orbit more slowly in the galaxy's outskirts, such as where our Sun resides, taking hundreds of millions of years. This irregular rotation prevents the disk from acting like a solid structure, extends spiral arms, and produces twisting patterns. Like a giant wheel, the galaxy moves, but one with a rim that trails behind its center. Density waves form the spiral arms. The Milky Way's spiral arms are not stationary star trails. Waves of greater density traveling around the cosmic disk create these patterns. Compressed gas and dust travel along these waves, causing star formation and illuminating the arms with new, brilliant stars. As other stars emerge behind them, these stars gradually drift out of the wave, giving the appearance of a self-sustaining structure. The arms are dynamic and constantly moving, much like pond ripples or traffic on a freeway. At a distance, they seem motionless. They are a dance of rhythm and substance from within, molded by time and gravity. It is frigid, collapsing gas that gives birth to stars. Star formation starts silently in the Milky Way's dark arms. Chilled to a few degrees above absolute zero, massive clouds of molecular hydrogen, often hundreds of light years across, wander through space. Gravity gradually establishes itself within these clouds. Little areas get denser and start to give way under their own weight. The gas flattens, spins, and heats as it descends inward, creating a protoar in the middle. A new star is created when nuclear fusion ignites as a result of increasing temperature and pressure over time. The brightest lights emerge from the coldest shadows, spun softly into existence by the silent force of gravity. The galactic field has the ability to disintegrate star clusters. Many stars are born in groups rather than alone. The same cloud of collapsing gas created tight clusters. For millions or possibly billions of years, these mutually gravitationally bonded clusters drift together. But eventually, they start to disperse. Clusters are pulled apart by internal dynamics, close interactions with other stars, and tidal pressures from the Milky Way's bulk. One by one, stars separate, causing the cluster to disappear into the galaxy's overall starfield. Long ago, even our Sun was born in a star cluster. Its siblings have now dispersed, faded, or vanished into the mists of time. There are old hypermetal-deficient stars in the cosmos. Hypermetal-poor stars are among the rarest and most valuable objects in the Milky Way. Stars with nearly no elements heavier than helium in their atmospheres. Less than 1/10,000th of the iron in the Sun is present in some of these. These stars, which have just slight signs of enrichment from a universe that is still forming, are thought to be among the earliest to be born following the first supernova. Like far-off lamps from the beginning of time, they are strewn across the halo and are extraordinarily old and pure. Each one is a luminous gravitationally linked signature from a long-gone era, a sort of relic. The Milky Way is home to planetary systems. Planets are a common occurrence in the universe. They naturally result from the creation of stars. A revolving ring of residual gas and dust envelops a newly formed star as it ignites. Particles in this disk cling to one another, accumulate mass, and develop into worlds. Planetary systems are widespread throughout the Milky Way. Some are huge, with frozen moons and gas giants. Some are small, with rocky planets clinging to faint stars. While some may be similar to our own, others may completely confound our assumptions. There are more than simply stars in the galaxy. It is filled with solar families and systems, each with its own potential, orbit, and equilibrium. The corrotation radius is close to Earth. The spiral arms in the Milky Way revolve more slowly than individual stars, resembling a flowing pattern rather than a stable structure. However, there is a specific distance from the center, known as the co-rotation radius, where the average star speed is equal to the spiral arm's own rotational speed. The Sun of Earth circles near this line. We might be able to avoid frequent spiral arm crossings, areas with higher star densities, more supernovae, and gravitational disruptions because of this delicate match in speed. We may reside in a more stable area of the galaxy, protected by resonance rather than walls. Through the cosmic plane, the Sun bobs up and down. The Sun does not travel in a completely flat orbit around the Milky Way. Rather, it travels in a soft wave, rising and falling over tens of millions of years as it drifts above and below the cosmic plane like a slow-motion cork. The gravitational attraction of the galaxy's mass is what causes this vertical oscillation. When the solar system moves, it is pulled and released. Although the data is still unclear, some experts have even questioned if this motion might affect Earth's extinction cycles. It serves as a reminder, though. The Sun is not gliding, even as it rounds the center steadily. It is gently moving over space. Dark matter exists, but we don't know what it is. The majority of the Milky Way's mass is made up of dark matter, which has never been directly observed. Light is neither emitted nor absorbed by it. As though it weren't there, it moves through regular matter. But there is no denying its gravitational pull. It keeps the galaxy together, explains why stars rotate at unusual speeds, and influences how large-scale cosmic formations form. The Milky Way would disintegrate without it. Instead of viewing it, astronomers can discover it by observing how it moves other objects. It is the silent, unseen structure of the cosmos and remains one of the biggest scientific mysteries. The disk's exterior has more mass than its interior. The flat, luminous disk contains the majority of the Milky Way's visible stars, yet the bulk of its mass is located elsewhere. Beyond the furthest stars, the galaxy is encircled by a massive dark matter halo. The galaxy is held together by this halo, which is much heavier than the disk. Although globular clusters and old stars make up a small portion of its population, its actual size is hidden. Our first impression of the Milky Way is of its starry plane and spiral arms. But that's just the surface that glows. The galaxy's mass, velocity, gravity, and reach are all mostly obscured by a silent shroud that covers everything. It's possible that the core of the Milky Way flared as a quasar. There is evidence that our galaxy's heart was once far more active than it appears to be today. The extraordinarily enormous black hole at the center may have once erupted as a quasar. a brilliant, violent beacon powered by infilling matter, as suggested by the presence of massive gamma-ray structures like the Fermi bubbles and evidence of high-intensity light reflected in nearby clouds. Quasars outshine entire galaxies, making them some of the universe's brightest objects. The Milky Way would have appeared as a spiral encircling a dazzling heart of light if it had previously burnt in this manner. The echoes are still there even after that time has passed. Over billions of years, the structure of the galaxy evolves. Galaxies are constantly changing, despite their seemingly eternal appearance. The arms of a spiral move. Bars are formed and then dissolved. Gas moves both in and out. The population of stars changes as they are born and die. Even the uneven, distorted, and rippling disk of the Milky Way is gradually changing shape. The structure can be twisted or bent by encounters with dark matter and dwarf galaxies. Like a drifting cloud, the galaxy's silhouette has changed over billions of years. Today's Milky Way is not the one that existed in the past or will in the future. Its gentle transformation, rather than permanence, is what makes it beautiful. Distant mergers cause gravitational waves to reverberate throughout the galaxy. Massive objects collide, black holes spiral together, neutron stars crash, and entire galaxies merge throughout the universe. These occurrences cause ripples in space-time itself and gravitational waves. Even though they are weak, some of these waves cause slight distortions to space as they move through the Milky Way. Although they are extremely hard to find, many have already been captured by observatories like Virgo and LIGO. The goal of new experiments is to find the gravitational wave background hum that permeates the universe. Space itself is changing even when you're sleeping. Not enough to sense, yet enough to let us know that the universe is changing in the distance. Some stars follow long, slanted orbits. Not every star orbits the galactic center in a straight line. Some are inclined at strange angles from the main plane, following lengthy, stretched ellipses that loop both high above and far below the disk. These stars most likely originate in separate places. Remnants of past gravitational upheavals or remnants of dwarf galaxies that the Milky Way has absorbed. Their orbits serve as hints and three-dimensional charts of the galaxy's turbulent history. Astronomers can recreate the invisible architecture of the Milky Way's mass and memory by tracking their velocity. These stars, twisted and stretched yet still connected to the whole, float like messengers from broken systems. We can hardly notice the neutrinos that the Milky Way emits every second. From the stars, trillions of neutrinos travel through your body. The sun, supernovas, and cosmic rays striking atoms in space all produce these spectral particles through nuclear processes. They are all over the Milky Way. However, they pass through practically anything undetected since they are so light and unreactive. Only a few are captured by specialized observatories buried under ice or deep underground. Light bursts from an uncommon collision. Information from invisible sources such as collapsing giants, star cores, and the galaxy's unseen energy is carried by neutrinos. They are cosmic fires whispers. There are things in interstellar space. It is a rough sea. Space is neither still nor smooth between the stars. Star motion, magnetic fields, and shock waves all cause the thin clouds of gas and dust that make up the interstellar medium to move. The temperature can fluctuate greatly. Material flows clash, blend, and break apart. Clouds fold, tumble, and stretch. Large-scale turbulence is produced by this, resembling a slow-motion ocean circling the disk. This restless sea influences cosmic rays, star formation, and even galaxy evolution. What appears to be serene starlight from a distance is actually a dynamic, rippling fabric that has been molded by ancient energies and invisible winds. There might be rogue planets in the cosmic halo. Not all planets are bound to stars. Some are subsequently expelled from their systems after forming regularly. There are some who might never have had a star. These are rogue planets, worlds that are isolated, icy, and dark, that are drifting in the cosmos. Studies indicate that there might be billions of them in the Milky Way, some even in the outer halo, where stars are few despite the fact that they are hard to find. They float invisible, without warmth or light. They are planetary drifters who travel long, lonely routes through the darkness between stars, warmed solely by their own internal heat. The cosmic dust flow is shaped by magnetic fields. Tiny carbon and silicon particles known as interstellar dust migrate due to the galaxy's magnetic field in addition to gravity. Like unseen currents, these fields flow through the Milky Way, directing the travel of charged particles and affecting the alignment of gas and dust. Dust grains in some areas spin quickly, giving off a weak microwave glow. In others, they polarize the starlight that travels through them by aligning with magnetic lines. Astronomers can track the structure of the magnetic field and even eliminate its influence from cosmic background studies by comprehending these effects. Dust is not a passive substance. It falls in mysterious patterns in the dark while dancing to a captivating beat. Neutron-star collisions enrich certain stars. One of the universe's most explosive events, a kilonova, is produced when two neutron stars collide after spiraling together. Huge amounts of heavy materials are formed in this brief, bright explosion. Uranium, platinum, gold, and more. After being launched into space, these materials combine with gas to produce new stars. Enriched in elements that could only have resulted from such collisions, certain stars in the Milky Way bear the chemical fingerprints of these infrequent occurrences. In addition to being bright bodies, they are also archives of past apocalypses that are blazing with the remains of star wrecks and cosmic alchemy. There might be a secret bar inside a bar in the Milky Way. A bar of stars, a lengthy bridge of light that spans the central bulge, is located at the center of the galaxy. However, astronomers have discovered evidence of a second, smaller bar that is inclined at a different angle and rotates on its own, deep within that bar. The motion of adjacent stars and gas reveals the gravitational impact of this inner structure, which is hard to view directly due to dust and distance. These kinds of bars could aid in feeding the extremely enormous black hole and influencing its dynamics by directing material toward it. The core of the Milky Way is not a single, straightforward shape. It's a dynamic, multi-layered maze of motion and light. The cosmic web provides the galaxy with gas inflows. There is no closed system in the Milky Way. Fresh gas from the intergalactic medium is drawn in by it. The cosmic web is filled with long, tenuous streams. By refilling what the galaxy gradually loses, these inflows supply the building blocks for future stars. Some of the gas enters the disk as silent, chilly filaments. Other streams glow up in ultraviolet or X-ray radiation as they fall in hotter, shock-heated forms. These unseen rivers connect the galaxy to the wider cosmos and support its expansion and development. The Milky Way is still fed by threads of matter spun from the early universe and draws from far-off reservoirs. Bubbles of hot gas emerge from the disk as chimneys. Big cavities are formed in the interstellar medium when groupings of big stars explode as supernovas. Together, this can form magnificent bubbles, which are enormous pockets of hot gas that rise through the galactic disk and release into the halo. The end effect is a route that allows gas, magnetic fields, and energy to exit from the galaxy's plane, resembling a chimney. These chimneys disperse metals, control the interstellar medium's pressure, and aid in halo structure formation. In this manner, the galaxy breathes not only inside the disk, but also through tall columns that radiate its vitality into the night. The galaxy emits X-rays from its black holes and ancient stars. The Milky Way flames violently in other wavelengths, yet appears serene in visible light. Its core, collapsed stars, and the edges of black holes all emit X-rays. Companion matter can be heated to millions of degrees by white dwarfs and neutron stars in binary systems. Faint X-rays are also released by hot gas in the halo, exposing the bigger skeleton of the galaxy. This high-energy light is invisible to the human eye. However, a very different picture of the galaxy is shown by telescopes like Chandra and XMM Newton. It was a world of intense heat, compact remnants, and concealed radiation, not a peaceful spiral. All around the Milky Way, pulsars serve as cosmic clocks. A large star may be left spinning quickly and precisely, with radiation beams spreading across space, when it dies and collapses into a neutron star. Some of these are pulsars, which rotate hundreds of times per second and pulse in predictable, regular patterns. Because of their reliability, astronomers employ them as cosmic timekeepers, monitoring their signals to test gravity, estimate distances, and even look for gravitational waves. Pulsars are silent, blinking stars in the Milky Way, leftovers of death, but also shining examples of incredible order. They tick slowly in the quiet between stars, keeping time not for minutes or days, but for entire epochs. The galaxy's hidden structure is mapped by radio waves. A large portion of the Milky Way is obscured by dust, distance, or faintness, making it undetectable to the naked eye. However, radio waves have the ability to pass past these obstacles and show otherwise invisible structures. They emphasize emissions from pulsars, supernova remnants, and even far-off quasars outside the galaxy, trace cold hydrogen gas and outline magnetic fields. Astronomers have measured the disk's warp, traced the spiral arms, and found star-forming regions hidden in darkness using arrays of radio telescopes. Radio soundings allow us to see where light is blocked. Science has learned to interpret the galaxy's unintelligible language into shapes and shadows. Most likely, a star cluster is where the sun was born. Seldom do stars originate alone. Typically, they are formed from the same collapsing cloud of gas and dust in the form of star clusters. Most likely, our sun was one of these. It was born in the same cradle as hundreds or even thousands of other sibling stars long ago. The cluster was gradually dispersed by the migration of the galaxies, gravitational tides, and passing stars. The majority of the Sun's siblings have strayed far and been hurled into various orbits, bringing with them fears of our common history. Some might still be shining close by, lost family in a sea of light, invisible amid the stars. The siblings of the Sun are dispersed throughout the galaxy. Astronomers are looking for the Sun's lost siblings, stars that have the same age, velocity, and chemical fingerprint as the Sun, even though its birth cluster has long since disintegrated. Researchers aim to find these long-lost cousins using spectroscopic databases and large surveys like Gaia. A few contenders have surfaced. The same cloud of enriched gas may have given rise to stars that were similar to our own. If discovered, they might provide information on the circumstances surrounding the formation of the Sun and the early solar system. We are not completely alone in our position in the galaxy. The Sun's old relatives might still be shining elsewhere. The spinning cosmic disk wobbles. The disk of the Milky Way is not entirely flat. Like a spinning platter that has been knocked off balance, it wobbles softly and ripples. The outer areas, where the disk bends upward on one side and downward on the other, are where this warp is most noticeable. It could be brought on by interactions with dark matter, internal asymmetries, or the gravitational pull of surrounding dwarf galaxies. Like a huge wave passing through the stars, the wobble spins gently. We can't sense it from Earth. However, the Milky Way is not a perfect spiral when viewed from a distance. It is a gently curved sheet of stars that is breathing and undulating. Star streams and clusters can be distorted by galactic tides. The vast bulk of the Milky Way exerts tidal forces on everything within it, much like the Moon's gravity pulls tides on Earth. The galaxy's unequal gravitational attraction is felt by star clusters, satellite galaxies, and even globular groupings. Long stellar streams may be drawn out, or stars may be peeled off their orbits as a result of these tides' gradual stretching and distortion. These interactions left behind many of the weak star arcs that are plotted throughout the sky. The technique involves the unraveling of clusters. Galaxies are progressively being ripped apart. These structures are not abruptly broken by the galaxy. Over millions of years, it gradually untangles them, strand by strand. The mass of the Milky Way is yet unknown. The mass of our own galaxy is incredibly difficult to measure, despite the fact that you may assume we would know it. Only a small fraction is made up of gas and stars. We are unable to directly detect the huge dark matter halo which contains the remainder. Estimates differ. A mass that is nearly 1 trillion times that of the Sun is proposed by some. Others rank it considerably higher. The ambiguity stems from the attempt to quantify the speed at which stars orbit at long distances, a process complicated by a lack of data and the impact of invisible stuff. Our home is the Milky Way, yet its weight is still a mystery. Perhaps it weighs more than Andromeda. Astronomers believed for a long time that the Andromeda galaxy, which is marginally bigger and brighter than the Milky Way, is also more massive. However, new observations indicate that the dark matter halo of the Milky Way might be denser and wider than previously thought. Even though Andromeda appears more modest, our galaxy might surpass it if that is the case. This is important for forecasts as well as comparisons. The mechanics of the encounter will be shaped by the relative masses of the two galaxies when they eventually merge. Though it may appear peaceful, the Milky Way is heavier than we previously thought beneath its silent spiral arms. It's possible that the Mellanic clouds are in their first orbit. It has long been believed that the Milky Way is orbited by the Great and Tiny Magellanic Clouds, two brilliant satellite galaxies that are visible from the southern hemisphere. However, current data indicates that they might be newbies who were only recently discovered in terms of the cosmos. Their mobility and speed in space suggest that this might be their first near encounter. If accurate, they are far-off nomads who are just now succumbing to the Milky Way's allure rather than lifelong friends. Their approach has distorted the galaxy's form and agitated the outer disk. The silence of the sky is filled with first meetings, as though the Milky Way is reacting to a new gravitational visitor. A ribbon of stripped gas called the Mellanic Stream. Behind the Mellanic clouds is a huge ribbon of gaseous hydrogen, a formation known as the Mellanic Stream. Stretching across the southern sky in arcs and bends, it spans hundreds of thousands of light-years. As the dwarf galaxies passed near each other and the Milky Way, tidal forces dragged this stream away. It manifests as a long-lasting whisper of motion and loss in radio frequencies, unseen in visible light. Like a thread of memory extending between galaxies, the stream might eventually settle into the halo or feed fresh star formation in the Milky Way. Polar orbits are exhibited by certain gas clouds. The disk's tidy plane is not followed by anything in the Milky Way. In highly inclined orbits, some gas clouds and even some stars pass above and below the main structure of the galaxy. These polar orbits most likely resulted from mergers in the past that grabbed stray clouds or dwarf galaxies at strange angles. Over time, they had persisted in their slanted orbits, resembling comets around a planet. These orbits that are out of alignment are evidence of disturbance, visible reminders that the galaxy is a dynamic structure molded by the erratic course of cosmic history rather than a closed entity. Past starbursts are surrounded by enormous gas shells. Astronomers have discovered massive spherical shells of gas in a number of Milky Way areas, some of which extend hundreds of light-years. The leftovers of strong starbursts, which occurred when groups of huge stars formed together, lived short lives and then exploded quickly one after the other, are these shells. Gas was blown out in all directions by their combined winds and supernova, which created enormous holes in the interstellar medium. The expansion slows down with time, but the shells are still there. Where the galaxy previously blazed brightly with stellar birth and death, there are ghostly bubbles. The remnants of cosmic fireworks that continue to reverberate in the cold are these, Occasionally, stars collide in concentrated areas. Stars are tiny, and space is vast. Nonetheless, stars can pass near enough to interact and even crash in the densest areas of the Milky Way, such as the centers of globular clusters. The outcome might be dramatic when they do. The creation of a rare blue straggler star, which seems younger than its companions, the merging of two suns, or a blast of light. Although they are uncommon, these crashes are not impossible. Gravity and chance can cause the tightest star neighborhoods to reorganize over billions of years. Time flows differently in these densely populated celestial cities, and space is never really vacant. Tidal forces have the power to tear apart binary stars. Numerous stars orbit one another in a gravitational embrace and live in couples. However, this link is also breakable. Tidal forces can upset a binary system's orbit if it travels through a dense cluster or near the central black hole of the Milky Way, causing one star to be flung out while the other is retarded or caught. Sometimes a partner is thrown completely out of the galaxy, turning into a rogue star that speeds through cosmic space. In locations we seldom ever see, these stellar breakups occur quietly, a hushed tearing of long-standing alliances by gravity's other hand. Some stars completely leave the cosmos. Although the majority of stars are gravitationally confined to the Milky Way, some stars can reach escape velocities of more than 500 kilometers per second and be launched into space, never to be seen again. Although they are uncommon, these hypervelocity stars exist. Some are believed to be expelled as a result of interactions with the galaxy's central supermassive black hole. Supernovae in binary systems or three-body collisions may slingshot others. They enter intergalactic space by themselves after being set free. Drifting well beyond the edge of the spiral are tiny lighthouses. They become lone travelers in the vast void between galaxies, carrying the galaxy's memory outward. Stars from other galaxies can be found in the Milky Way. Not all of the Milky Way's stars were born here. Some might have been thrown into our halo from far-off parts of the local group, caught during mergers or formed in neighboring galaxies. These cosmic nomads frequently follow strange orbits that lead them across the halo or fringes far from the disk. Stars that don't exactly fit the local patterns can be recognized by their velocity or composition. They bring tales from many settings, eras, and skies, much like cosmic immigrants. The system of the Milky Way is not sealed. It is a dynamic mosaic that is gradually put together by motion and time. The galactic fountain is a silent loop of gas rising and falling between the disk and halo, above and below the brilliant disk of the Milky Way. Material is heated and ejected upward into the halo by star winds and supernovae, where it cools, condenses, and then gently rains back down over millions of years. This cycle helps control star formation, redistributes heavy elements, and stirs the interstellar medium. Between the broad halo and the dense plane, there is a silent breathing motion of matter. In this sense, the galaxy does more than simply revolve. It moves about. Over a vast amount of time, it breathes in and out, maintaining its structure. Organic substances are carried by the dust grains in the galaxy. Scientists have found complex organic molecules, which are carbon-based substances that are the building blocks of life, among the clouds of interstellar dust that drift between stars. These consist of simple sugars, alcohols, polycyclic aromatic hydrocarbons, and more. Despite not being living, they are chemically rich and were created in frigid, radiation-shaped clouds, or the atmospheres of dead stars. Galactic winds carry these tiny grains across light years, where they settle into the gas that creates planets and stars. The early Earth might have been hit by some of them. The dust of the galaxy is more than simply trash. It is a load of possibilities floating through the night in silence. Solar systems may receive life-giving elements from interstellar clouds. Worlds are born in the same areas that stars are born. Planetary systems acquire the chemical signatures of their parent nebula as they develop from collapsing gas and dust clouds. Water, carbon compounds, and other biological building blocks may wind up in comets, asteroids, or planets if they are present in that cloud. Such primordial chemistry is particularly abundant in some areas of the Milky Way. Although the prevalence of life is unknown, the prerequisites for it appear to develop spontaneously. Perhaps the seeds of life are strewn everywhere, nestled in the coldest cradles of the cosmos, waiting to find a home. Compared to the Sun, some stars rotate hundreds of times faster. While most stars rotate, others rotate so quickly that they complete a full circle in a few hours. With bulging equators due to centrifugal force, these fast rotators are frequently young, large, and unstable. Some accelerate to such high speeds that they launch debris, encircling themselves with luminous disks. Depending on latitude, the Sun spins once every 25 to 35 days. However, these fast-spinning stars are getting close to their physical boundaries as they rotate hundreds of times faster. Their evolutionary histories and internal architecture differ. Even though their lives are short, they whirl like sirens in the night. In relation to the ecliptic, the galaxy is tilted. Although the Milky Way is a beautiful bar of light that arcs across the night sky from Earth, it is not in line with the plane of our solar system. The ecliptic, the path taken by the Sun and planets, is about 60 degrees off the galactic plane, the flat disk that contains the majority of the galaxy's stars. The Milky Way rises at an angle and changes position with the seasons because of this tilt. Although our small system is slightly skewed, we are a part of the galaxy, a little slanted boat floating in a vast, whirling sea of stars. The disk of the galaxy is not as ancient as certain star remnants. White dwarfs, which are the cooling cores of brilliant stars older than the Milky Way's narrow disk itself, have been discovered by astronomers among the feeble stars in the halo. Before the galaxy's main structure had completely settled, these primordial relics formed. Their presence suggests a more ancient star formation period, a more profound past engraved in the outer halo. The silent remnant of a moment when the Milky Way was still taking shape is carried by them as they gradually fade after burning for billions of years. The halo remembers farther back, even though the disk is bright. The stars that are the furthest out from the main structure orbit far away. The most distant stars in the Milky Way orbit tens or even hundreds of thousands of light-years from the center, well beyond the well-known spiral arms. These stars take billions of years to complete a single orbit, traveling slowly and widely around the galactic halo. Many are currently wandering in the furthest reaches like far-off sentinels, most likely taken from smaller galaxies in previous mergers. Although they are few, dim, and distant, they contribute to the definition of the galaxy's size, form, and gravitational pull. There is more to the Milky Way than meets the eye. Shaped by wanderers at its edge, it stretches far into the darkness. The Milky Way is asymmetrical in a number of ways. The Milky Way is slightly uneven, despite being frequently depicted as a symmetric spiral. The disk has a thicker side than the other. The brightness and breadth of the spiral arms vary. The stellar halo itself is a little off-center. These asymmetries most likely result from prior mergers, dark matter clumps, or gravitational interactions with the melanic clouds. The universe is not a flawless pinwheel. Like a whirling dancer whose skirt has been caught in the wind, it is a living structure characterized by tugs and twists. That irregularity, a tasteful unbalance carved by time, is what makes it so beautiful. Variable stars are used by astronomers to map the galaxy. Like sluggish, dazzling heartbeats, some stars pulse in brightness at regular intervals, expanding and contracting. These are variable stars, and there are recognized correlations between the brightness and pulse period of some types, such as Cepheids and RR. Astronomers can calculate a star's distance and true luminosity by observing how long it takes for it to shine and fade and comparing the two. By acting as cosmic yardsticks, these stars assist us in charting the Milky Way's size, composition, and form. The dark blinking beacons strewn around the spiral are LEDs that measure. Our knowledge of the Milky Way is being revolutionized by the Gaia project. The Gaia spacecraft, launched by the European Space Agency, is producing the most accurate depiction of the Milky Way to date. Gaia provides information about the galaxy's three-dimensional structure and mobility across time by analyzing the positions, movements, and brightness of more than 2 billion stars. It has mapped the disk's warp, discovered streams from torn galaxies, and meticulously charted the Sun's orbit. Gaia expands our knowledge with every new data release, transforming a fuzzy patchwork of stars into a precise, dynamic map. It is the most ambitious star chart in astronomy, showing a silent revolution among the stars. A dense star path is marked by the galactic plane. On a night without city lights, you could notice a blurry river of starlight flowing across the sky. The thickest portion of the Milky Way's disk is known as the galactic plane. The bulk of the galaxy's stars are located in this enormous flattened band, which is not a line. Star formation is frequent, dust is layered, and stars are closely spaced throughout this plane. From our position, we are staring into the galaxy's most opulent passageways along its grain. This band is more than just gorgeous. The majority of stars reside and pass away in this congested, bustling center. The galactic core is where the night sky shines brightest. The Milky Way's core is located toward the constellation Sagittarius, which is a dense, luminous collection of stars, dust, and invisible matter. The very center is not visible to us from Earth. Our view is obscured by dust clouds, but the region is bright in radio and infrared. The area seems more densely populated, brighter, and filled with the overlapping light of billions of stars, even to the unaided eye. We orbit in a peaceful galactic disk suburb, far from this core. Looking inward, however, we see the bustling metropolis at the center of the galaxy. From Earth, we can see the Milky Way, John. We can't look down on the Milky Way from above because we live inside it. Rather, it appears to us from within as a flat ribbon of stars that is only curved by the horizon. It is difficult to understand the galaxy's complete structure from our point of view because this John view condenses it into a single arc. The spiral to which we belong was discovered after centuries of observation, classification, and mathematical inference. From Earth, we see through its disk as if we were standing in a forest and following the tree line. We only perceive the expanse that envelops us. We do not see the shape of which we are a part. There is far more in the galaxy than humans could ever see. We can only see a small portion of the Milky Way, even with our most sensitive detectors. Dust blocks light. Silence conceals motion. Luminous stars are outnumbered by dark matter. There is promise in every empty space and vacancy between every star. There is more to the Milky Way than meets the eye. It is what we want to know, what we guess, and what we deduce. It contains drifting worlds, future stars, ancient light, and unanswered questions. And in that immensity, we somehow find ourselves floating through a story too big for the eye. One planet among many, orbiting a silent star. And now, behind your thoughts, the stars start to fade. We have wandered through 100 silent realities. From dust and gas to light and darkness, from newborn suns to long-dead leftovers, from the warp of the galaxy's disk to the furthest halo stars, and everything in between. You have danced down spiral arms, explored through stellar nurseries, and looked toward the galactic heart that glows behind dust veils. This galaxy contains you, not merely a traveler on Earth, but an active participant in its protracted and bright development. Stars were used to forge the iron in your blood. Ancient explosions molded the oxygen you breathe. Your body's atoms are descended from the same primordial substance that today powers suns and drifts through clouds of cosmic dust. The cosmos turns on tonight while you're sleeping. There are stars forming. Light is moving. Orbits remain silent. You're floating inside it too. Nestled in the spiral arm of a calm, glowing sea, a tiny glimmer of warmth in the darkness. Now is the time to view the following chapter, if you are still awake. I wish you a restful night's sleep and peaceful dreams.